14.6 is nothing new. When I was looking at these notes, when I was getting ready to, I go, why do I need to write any extra notes when they're already covered in 14.3? 14.3 has some questions that your answers are in the quadratic formula and things like that. But these answers, you might find whole numbers, which is kind of nice. You might use the quadratic formula. It might factor just a little bit. So nothing new in 14.6. Matter of fact, you have several even questions, and I thought, man, they probably could do them all. I might even have next year's class do them all, to be honest with you. But I decided we'll stick to the evens because that's what's on your check sheets. And instead of me doing examples from the evens, which I normally do a problem or two for you, I'm going to do the odds. And I have only 2 examples. And then you will have the rest of the time to do your homework in class. So I picked number 17. The reason why I picked number 17 is because if I'm trying to do this problem, because there's an equal sign, I can get rid of the fractions. I can clear the fractions by multiplying by the LCD, the common denominator. I can take this equation and multiply every single thing by the common denominator. And I chose this one because I looked at this one and I said, it has an x, this has a 2x, and this has an x plus 7. I need to think of this as a group. I need to think of this as a monomial of 2x. And I could get x to go into 2x. I just need a 2 there. So I'm hoping you know what your LCD is. If you know what your LCD is of number 17, tell the person you're sitting next to, please. I am hoping that you would say 2x times an x plus 7. You have to have a 2x and you have to have an x plus 7. Those are separate things. Don't try to put a plus 7 with an x and think that that's going to work. You have to have these monomills. What can go into the monomills? The 2, we need a 2. We need an x and we need an x plus 7. That's how it's going to work. If you do the right LCD, when you multiply every single thing by the LCD, the denominators go away. For example, if I put this right here, let me just put it up in the numerator, 2x, x plus 7 there, 2x, x plus 7 there, and then right here, 2x, x plus 7, there it goes, 2x, x plus 7 there. So that goes to all 3 things. Like it distributes basically. I'm just going to do that for the record. If I do that right, then these little denominators should go away. If I do it right. X plus 7 times 1 is x plus 7. The x plus 7 goes into x plus 7 one time. You're left with 3 multiplied by the 2x. 3 times the 2x is plus 6x. Bless you. Equals. If I do this right, the x is going to go into the x that's in front. Because that x in front is multiplying the whole group and is not with a plus 7. I can't reduce the x in the x plus 7, by the way. It has to be the one that's in front. So what I'm left with is this 2x plus 7 times a negative 1. It has to multiply that negative 1. So I'm going to put it like this. I'm going to put this negative right here. And I'm going to take this negative 2 and multiply it in and get negative 2x minus 7 right here. Minus 14. Thank you very much. Minus 14. Once you get there, you don't have any fractions to deal with. And the only way you can get rid of fractions is if it's an equation. All the problems are equations in section 6. Do not try to get rid of fractions in any of the previous sections except for section 3. Keep that in mind. I'm going to put these together. X and 6x makes 7x plus 7 equals negative 2x minus 14. I'm going to add the 2x to this side. I'm going to get 9x. I'm going to subtract 7 over here and get negative 21. And then I'm going to divide by 9. Divide by 9. Divide by 3. Divide by 3. And I'm going to get my answer. One thing you should always do when you get to your answer is you should check to see, can I use it? Will this cause me to divide by 0? I always want to go back to section 1 and think, is this a part of my domain? And why do I say that? Because there's going to be a test question, I promise you. Since I'm using a lot of the curriculum from Algebra 2. In Algebra 2, we made sure we tested, are they checking their domain? Is it possible? There will be one tricky question in there that this is not the answer because it's not a part of the domain. Keep that in mind. Just like that quiz, that homework question. The last example I have for you is number 19. The reason why I chose number 19 is because of 2 reasons. Because of this 2 that doesn't have a denominator, or that the denominator is an invisible one. And I chose number 19 because this fraction here, this denominator, is not factored, and I always recommend that you factor it first. Let's see, what 2 numbers multiply to be negative 6 but add to be a positive 1? 3 and 2? Is the 3 positive or is the 3 negative? I always double check. Positive 3 times negative 2 is negative 6. 3x minus 2x is 1x. That works. I always do that before I cross this off. Like I go, okay, this is the same thing as that. That helps me. Now I can look at this denominator and this denominator and this denominator, and I can turn this into the same problem that we had before where we look for our common denominator. This has a factor of x plus 3, a group. This has a group of x minus 2. This has a group of 1, which really doesn't change anything. And this has a group of x minus 2. Now I know what to multiply by. Now I know what my LCD is. If you know what your LCD is, or the LCD of 19, tell the person you're sitting next to what you think it is. I'm hoping you said x plus 3, x minus 2. And I'm hoping that you're going to put next to each term, including the 2. That's a term. Terms are separated by plus signs and minus signs. We're multiplying every single piece of this equation by x plus 3, x minus 2. I leave it in factored form. That way, I can see what reduces. This left side just equals 5. This right side, I have a 2 times x plus 3 times x minus 2. Well, guess what? That is the same thing as doubling this. X plus 3, x minus 2 is the same thing as this x squared plus x minus 6. I just have to take 2 and multiply this by 2. So what I'm going to do is this part in my head. I'm going to just say 2 times that is 2x squared. 2 times that is plus 2x. 2 times the negative 6 is negative 12. what I am doing is I'm taking the 2, and I already know what that is because I factored it earlier, and I'm just doing this part in my head. Over here, this x minus 2 and this x minus 2 reduce, and I'm left with x minus 3 times x plus 3. I have to multiply that. I have to FOIL it out. Good thing I know it's a difference of squares. When I FOIL that out, it's x squared minus 9. So now all I do is combine like terms. Since these are on the same side, I just put them together. 2x squared plus 1x squared. Since they're on the same side, we just put them together. It makes 3x squared plus 2x. I'm going to subtract this 5 at the same time. That way it's equal to 0. And we have negative 12. Negative 9, negative 5, negative 14. How about negative 26? Is that what you guys got? Mm-hmm. Thank you. That gives me more confidence. Factoring. Do I factor it? Do I complete the square? Do I do the quadratic formula? I'll appease you. Let's do the quadratic formula here. Opposite of b, plus or minus. Radical b squared is 4 minus 4 times a times c all over 2 times a. You can only, I have to say this because somebody in my 7th period asked me this, can we use the quadratic formula for like this part? I go, well, only if you know what it's equal to. Now, since we know this is equal to 0, now we can factor using the quadratic formula. So I'm going to do this on my calculator just because I don't know what 12 times 26 is. That's 312. Negative times a negative is a positive. 312 plus the 4 is 316. And 300, this is the square root of 316. I'm just going to put a little line that's 316. And the square root of that is 2 root 79. It looks like this equals negative 2 plus or minus 2 root 79 over 6, which reduces. I can reduce because this goes in and this goes in. I can divide this by 2, divide this by 2, and divide this by 2. I get this. Negative 1 plus or minus root 79 all over 3. I would also accept negative 1/3 plus or minus root 79 over 3. These two answers are equal to each other. I would also accept this if you split it. I'm going to stop your notes right there.